Hello friends, welcome back to my channel. Now in today's video, we are going to look at how to log an application that's running on a Kubernetes cluster. And for that, we are going to use Elasticsearch, Filebeat, and Kibana. So Filebeat is going to collect our logs. Elasticsearch will index the logs and also make it available for Kibana to display it on the dashboard. Now for all of this, our application is deployed in a Kubernetes cluster. So you have a cluster setup, and these apps, Elasticsearch, Kibana, and Filebeat will all be running as Docker containers in our Kubernetes cluster. Please join me as we embark on this project from start to finish. And if you have any questions, keep it in the comment section below. The link to the GitHub repository for this project is also in the description below. Like, comment, and subscribe to my channel for more videos like this. And now let's get into it. So for some requirements, in our ELK stack, we are going to use Elasticsearch, Filebeat, and Kibana. Kibana will be a dashboard for displaying the logs. Elasticsearch will be the collection of the logs. And Filebeat is what's going to do the scraping. It will take the logs and transfer them to Elasticsearch. And Kibana is going to display them. We have a few requirements here. We need Docker installed, kubectl, and Minikube. I'm working on an Ubuntu system, so I already have these installed. If you don't know how to install Docker, kubectl, and Minikube, I already have videos on my channel. Go to my channel and you'll find videos on how to install them, or you can just Google them and install it. I've used it too many times in several videos, so feel free to check them out. All right, I have a lot of files to deal with, so I'm going to use Visual Studio Code for this project. I have a directory called final, and that's where all the files in the GitHub repository are. By the way, I have a link to the GitHub repository in the description below. So I run code dot in my terminal, and that should open my Visual Studio Code. We need our terminal, so new terminal. And here is our README. I have all the commands here, so you can just copy and use them. Okay. So from our README, you can check the Docker version. That's Docker installed. And check the kubectl version as well. The kubectl is also installed. And of course, we are going to use Minikube to set up our cluster. So that also needs to be installed. And this is clearly installed as well. And all these commands I'm copying are in this README. Since all that is installed, I can go ahead and create my Minikube cluster. Elasticsearch can be quite intensive on the resource of your computer. So I'm going to apportion 4 CPUs and 4 gigs of memory. And since Docker is installed, I'll use Docker as my driver. So I'll copy this, paste it in the command, and that will create my Minikube cluster. So give it a few seconds and it should be ready. Okay, it's ready. So let's check if you have a control plane node. Don't forget, Minikube has only one node. That's a control plane node. So we can go ahead and create some applications. Now I'm going to deploy these sample applications in a namespace called demo app. So I need to first create the namespace. Now namespace is just to isolate the resources. Okay, it's going to isolate everything. So if I create any resources inside this demo apps namespace, it isolates it from everything else. Okay, so run that to create the namespace. If I do kubectl get namespace, see, this is the namespace we just created. Next is to create app 1. Right now on our GitHub repo, let's go back to the repository. This is app 1. Now this is a pod that's running the Busybox Docker image. Okay, Now it's gonna display this information. If a shell is true, then it's gonna display hello from app 1, or the application will be logging this information, exactly the hello from app 1. And this is the namespace we just created, and it has labels app 1 everywhere. So this is what we are creating by running kubectl apply -f app1.yaml. Press enter. That's done. Now I have 2 applications I'm deploying. So that is app 1. Another one is here, app 2. Gonna paste that too. Now app 2 is also very similar. It's the same image or container. It's outputting hello from app 2. And this has labels app 2. And this is also a pod, which is going to be in the namespace demo apps. Right. If I run kubectl get all -n demo apps. So these are the 2 apps I just started or just created. All right, back to the README. So we've created our demo apps in the correct namespace. And so the next step is to create our Elasticsearch deployment. I want to isolate everything. So for the Elasticsearch, I'm going to run it inside the login namespace. So first, I'll create a namespace called login. Using this command, that creates it. Then I'm going to go ahead and create the Elasticsearch using the Elasticsearch script file, which is a YAML file. Before I run that, can copy it, but before I run it, let's go to the Elasticsearch script here. Even though Elasticsearch is a deployment, so we need a deployment and a service, but the data that Elasticsearch is going to collect, which are the logs of the applications, have to be stored. So we need to attach some persistent volume to it. Okay. Now, so this is a simple deployment starting from this point with the labels. The labels are Elasticsearch, and the container I'm using Elasticsearch 7.17.0. Okay, and some environment variables here that are important for Elasticsearch, and it's listening on port 9200. Now this is a mount path for our persistent volume. So you see a volume mount declared here. If you want to declare or mount a volume in a deployment, you specify the volume and then you mount it inside the container. So this part here is inside this container, which is the Elasticsearch container. And this is defined outside of the container. In order to mount a volume for a deployment or for a pod, you create a persistent volume and then you create a persistent volume claim so that whichever resource that needs it will go through the claim to retain it or to get bound to it. But because we are using Minikube cluster as our Kubernetes cluster, we don't actually need to create the persistent volume. We just need to create a persistent volume claim, which is a PVC. It has some name. This is also going to be in the login namespace. It has read-write once access, and it has about 2 GB of storage. And then we give it some storage class name, and that is standard. Now, what this does is, as soon as Minikube sees that, Minikube automatically creates the persistent volume and then uses this persistent volume claim here to attach it to this deployment. Now, that's, of course, an automated thing in Minikube. It doesn't apply to all Kubernetes clusters. So in something like EKS from AWS or GKE or Azure Kubernetes, you will need to set up your persistent volume and your persistent volume claim and then mount it in a container like we've done here, and also reference it outside of the container in the deployments as we've done here. Okay. All right. That aside, the next thing is a service. You have a service here for Elasticsearch, also in the same namespace login, and it's listening on port 9200. So that's our Elasticsearch script. Let's go back to the README. And now we can create our Elasticsearch deployment. Copy that command, paste it here, and press enter. So it creates the persistent volume claim here, deployment, and service, 3 resources. Now this will take a few seconds to get ready, so pause for a few seconds and get back to it once it's ready. All right, let's check our resources. So I'll do kubectl get all in the login namespace. And you see here a deployment ready. You have the service is also ready here. And the deployment has a pod that's running and has 1 replica set. For the persistent volume and claim, you have to run kubectl. All right, this is the persistent volume PV, and it's already bound. You can see that here, and it's bound to Elasticsearch PVC, which is the persistent volume claim that we created. And the storage style here is standard. That's what we specified in the Elasticsearch script. This has storage class standard. Okay. Let's check the PVC as well. Use the same command and change this. And that is the PVC. And it has read-write only access. It's also standard, 2 gigs as we defined. And it's bound by the PV or the persistent volume. So Elasticsearch is set up now. And so the next thing that we need to do is to deploy Kibana in order to visualize our logs. Before we create our Kibana, let's examine our Kibana script or YAML file. This is it. And this is a deployment file. You have the Kibana deployment right here. And then we have its service right there. Of course, the name is Kibana and it's in the login namespace. You have 1 replica. And the app labels for Kibana is just Kibana everywhere. And then for Kibana, we are using the Kibana image 7.17.0. Now, we need to specify the environment variable for Elasticsearch host in our Kibana infrastructure. Now, remember, our Elasticsearch runs on port 9200. So Elasticsearch _ host, which is an environment variable, has this value, HTTP Elasticsearch port 9200. Now, this is a route that the logs will pass through from Elasticsearch to Kibana for the logs to be displayed. A Kibana container has port 5601. So from there, we define the service. Also in the namespace login. Now this service is of type node port. You can use load balancer if you have access to that. But since I'm using Minikube cluster, I can use node ports for this. And of course, the port is 5601. And then for the node port, we have the port 3601. Now I'm using node port because we need to access the Kibana UI on our browser. If you want to expose anything or an application in Minikube, you can use a node port. So that's what we are doing here. Go back to the README. And now we can create our Kibana resource. Paste it here. Press enter. And you see deployment and service created. Give it a few seconds for it to be ready. All right, let's check our Kibana resource. So I'll just check the status of all the pods in login namespace. So you see Elasticsearch pod is running and Kibana pod is also running. Now that it's running, we need to access the Kibana UI. So I will use this Minikube service, which is SSH tunneling command for Minikube, to expose the URL for my Kibana service. So I'll run that, but sometimes when you run this, it will keep loading. So it's appropriate to use a new terminal or a dedicated terminal for that. So I'll paste it here. Press enter. Okay, so this exits out of it. It just shows you the URL. So just copy this URL and paste it in your favorite browser. Paste and go. And that is our Kibana UI. All right, let's go back to our README. Now that we've exposed it in our UI, we need to set up Filebeat. Now, Filebeat is what's gonna collect the logs and then redirect it to the Elasticsearch. And then Kibana takes the logs from Elasticsearch and displays it on the dashboard. So we are gonna do the deployment for Filebeat next. Because there are several applications that may be running on a Kubernetes cluster, you know that I have the app 1 and 2. These two both running on the demo apps namespace. We have Elasticsearch that is running on the login namespace. We have Kibana that is also running on the login namespace. Right. Now, how can we collect the logs of all these applications? And later on, after setting this up, I'll create another application to kind of show how to do that. And so because of that, we need logs from all apps. So I'm going to deploy Filebeat as a DaemonSet. Now, DaemonSet is not too different from a deployment. It looks actually very similar. The only difference is a DaemonSet is a Kubernetes resource, or it's a kind of Kubernetes resource that runs on every single node or every single pod. So unlike a deployment that may be running on a single node or a single pod, this runs everywhere in every namespace and so forth. So I have a Filebeat Kubernetes manifest file here from Elastic. You can click this to download it using this curl command. Now, when you download it, you have to modify it a little bit, because when you download it, there is an Elasticsearch underscore host, which is an environment variable we defined inside Elasticsearch. We also define this inside Kibana. You need to give the value of this Elasticsearch host inside the Filebeat DaemonSet resource. And that's basically the name of the deployment for the Elasticsearch. We called it Elasticsearch. The namespace, we called it login. And we expose its service to it. It's running on port 9200. You can check it again from the Elasticsearch file. This is it. It's running on 9200. Okay. And its service is called Elasticsearch. So that's why in the Filebeat, we need to provide this link as an environment variable for that. In the Filebeat resource or the YAML configuration, we can add the namespace demo app or login, but it really doesn't matter. You can, of course, add the namespace to the DaemonSet annotation as part of the metadata. That's if you are doing namespace specific logs. Okay. Now, if you are not doing namespace specific login, then it's not even necessary to specify the demo apps inside the DaemonSet. Because by then, since it's already a DaemonSet, it's going to go across all pods and collect all the logs anyways from all namespaces. And it does this by using a cluster role. And this is all defined inside the Filebeat YAML file. So let's go to the Filebeat YAML file right here. And this will be the command I will use to run it. But let's go to the file first. First, we have a config map. And in Kubernetes, we use config map to cite environment variables or reference or store environment variables. Another way is to use config map to decouple some applications. If you have an application that has dependency on another thing or another application or another pod, instead of running it together, you can decouple it and you can use the config map to kind of piece them together after decoupling. We are calling this the Filebeat config map. In the login namespace, again, I want all the ELK stack in the same namespace login. And then for the labels, calling it Filebeat. Now, if you look here, filebeat.yml, that's the data. This is going to run, of course, as a container, but look at the path. So it needs to identify where logs are usually stored for any application. Now for container applications or applications that run in a container regularly, the logs are stored in var log/containers, and you see all sort of files .log. Now if it's not a container, let's take for instance NGINX. You can Google NGINX logs location, and that is var log NGINX. Okay, that is for normal NGINX. If it's a container, then its location is going to be var log NGINX container. So that's something to note there. So that is a path here as well, log paths. If you want to enable hints based on auto discover, then you can uncomment this part. But right now we don't need that, so we will ignore it. Next, here is where I said it earlier. In the README, we have output.elasticsearch. So that is where when the logs are collected, it has to go to Elasticsearch, right? This is a URL or the Elasticsearch host address that we used earlier. You have a username and you have a password. This is very important. This is what I referenced in the README. Let's go back to see this. In the README, this is the Elastic host. Back to our file. Now we can define our daemon set. So we are calling the Filebeat in the login namespace. It's attached to some service account, Filebeat. The image we are using to run the Filebeat is Filebeat 7.17.28. And then here are the environment variables. Of course, this will pick up the filebeat.yaml that we defined up here inside the config map. This file starts from here up to this end. So instead of defining it all inside this daemon set, we've decoupled it using a config map, as I was explaining from the beginning. And then of course the environment variables, Elasticsearch host, they're calling it Elasticsearch, and then the port number, username, password, and stuff like that. Now you can also give it resources. You have some volume mounts here. And then because the daemon set has to run on every single node or has to have access to every single pod, we need to provide it some cluster row abilities. And to attach a cluster row, you need to attach it using a cluster row binding. Okay, so that's why we have this cluster row binding here. We also have a row binding. That's all for the work of the daemon set. This is another row binding. Now you can examine all of these, and this is a cluster row. Now if you look at the cluster row, this is just the API groups. So the cluster row says this daemon set has access to namespaces, pods, and nodes. So it has access to all that. And the verbs, these are the actions that the daemon sets can run. So we can get, we can watch, and we can list. We have some more. Remember earlier there was a row binding. This is its row. And then this is the service accounts that is being referenced up here. It's referenced almost everywhere. Yeah, this is a service accounts reference and so forth. Okay, so that is the file. You can download this. Again, the link to this is in the description below. Right, back to our README. So I've basically downloaded this and modified it using this instruction. And so we can go ahead and apply our command. Paste it here, press enter. And that creates config map, the daemon set itself, cluster row, row bindings, cluster row binding, and then the other two rows and our service account. This may take a while to come up, so give it a few seconds for it to get ready. All right, let's examine our resource. Again, I'll get the pods in login namespace. So now you see all three of them running. You have Elasticsearch, Filebeat is also running, and Kibana is also running. Okay, at this point, we are gonna try to explore our Kibana dashboard with the logs that are being collected at the moment. Now, so far, if you want to see the logs that are being collected, you can run this command to get the logs for the app 1. Now, this can be a bit long, so I'm cutting it short with the pipe command and the tail. This will print only the last 10 lines of the logs. Paste this here. And this is what it's outputting. Hello from app 1, 10 lines. For the app 2, run a similar command. This one I'm using the pipe command and head, which is going to print the top 10 lines. And that is saying hello from app 2. So we will explore on the Kibana page. So let's go to our Kibana page. Click these 3 lines here. Scroll all the way down to stack management. Scroll down to Kibana. Under Kibana, go to index patterns. Create an index pattern. And then over here, we use Filebeat. You can see some indexes and aliases here. So I'm going to use Filebeat. Now, if you see this, you see Filebeat dash something. That's a random string. So I'm going to use Filebeat dash star. Star representing whatever comes after the dash. And then for the timestamp field, I'm going to use timestamp. Now I'll create this index pattern. So you see that our index pattern is created and saved. All right, let's go back. So I'll go back to discover right here. And now you see all the logs are coming in. All right, so these are all logs coming from either Elasticsearch, Filebeat itself, Kibana, app 1, and app 2. Okay, these are all logs coming from them. On the side here, you see all the fields that are available. If you scroll all the way down, you see some information here. Go to messages, and you see hello from app 1, which is exactly what you see here. Hello from app 2. This the logs that are coming from app 2. And some other logs that are coming from the other applications like Elasticsearch, Filebeat, and Kibana that are also running. If you want to see more, you can also see the file path for the logs. So app 1, the file path is varlog containers app 1, varlog containers app 2, varlog containers Filebeat, varlog containers Kibana, varlog containers Elasticsearch. Right. So don't forget this. I've had this in an interview before in the past where they asked what's the location for logs inside a Linux machine. So you should always know this. If it's a container, it's varlog's container and whatever application it is. If it's not a container but a VM or a server, then it's located inside varlog. And then the application, if it's NGINX, this part will be varlog NGINX. Right. Good. By the way, all the instructions here, I have listed them out right here so you can follow them easily. Let's do some exploration on this page. So I'll just add a filter. So go to add filter, and on the fields, I'll go to Kubernetes. Let's use labels.app. Operator, let's use is, and the value, let's say we want to view logs from app 1. So select app 1, save, and these are logs from app 1. And you see it's highlighted here. All these are logs from app 1. You can also click this greater than sign here to see more details, right? Or you can also collapse it by clicking on it. And this is logs from the last 15 minutes, as you can see up here. If you want to change it and add a new filter, again, we are looking at Kubernetes. You have container names, deployment, daemon sets, almost every resource in container you want to find is in here somewhere. Let's use the same labels app. is. Now let's look at the Elasticsearch's logs. Save this. And these are logs from Elasticsearch. If you want to see more, you can just go up here and change the time span. You can do last 15 minutes. You can do a day, last 24 hours, and so forth. Close it. And you're now back to seeing all the logs. And there are some more fields on this side. Anything you want to see or anything particular that is important, you can examine it, and that will give you more information about the logs. All right. Okay. Now for the last part of this project, we are going to deploy a new application, which is an NGINX application. Remember the first apps, app 1 and app 2, we deployed it before we set up the login. How can we now set up a new application and still add it to our login using Elasticsearch? So I have an NGINX deployment file here. Let's go in there. We will come back to the README file. You have a deployment, NGINX, and this is deployed in the demo apps namespace. Labels are NGINX, and we are using the NGINX latest Docker image, and it has port 80. And its service is NGINX service, and it's in the demo apps namespace. This is also a node port. We specify the port we want to use, 380, so we can access the NGINX UI on our browser. Okay, so back to our README. I will just apply this, run this, press enter, and that creates the deployment and the service for NGINX. Give it a few seconds to get ready. Now, since NGINX is also running in a demo namespace, I will run this command, and you see NGINX pod is also running alongside the pods for the app 1 and app 2, and everything is up. Since we want to access NGINX UI, I'll copy this command. This is also the SSH Minikube tunnel command that we used earlier for Kibana. Very similar. Only difference is you need to specify the service name for NGINX. NGINX service, we called it NGINX-service, which is right here. Right. And then in the namespace and --URL should give you the correct URL. So on this other terminal, I'll paste it, and that is our URL. Copy it, go to your browser, open a new page, paste and go, and that is your NGINX service. Okay, so NGINX is up. Because our Filebeat is already running as a DaemonSet, we don't even need to do any setup, because the DaemonSet gives it access to namespaces, paths, and one more thing. Let's see. So it gives it access to nodes, paths, and namespaces, and we can get, watch, and list. Okay, so indirectly, Filebeat is already set up to configure NGINX init. So let's go back to the Kibana page, refresh this. If I go to messages, now you should be getting logs from NGINX. You don't see it here, but let's go to path. Yeah, so that is from an NGINX port. That's logs coming from an NGINX part. This is from Kibana part, and that is from Filebeat's part. If you want to filter properly, add a filter. Select Kubernetes, labels.app, this, and you see NGINX there. Select NGINX, save, and these are NGINX logs, the last 15 minutes. We just put it up so the logs aren't that much. If you want to edit it, let's select Elasticsearch. These are Elasticsearch logs. Select a different app. Let's use Kibana. These are Kibana logs. App 1 or app 2. These are app 2 logs. And finally, these are app 1 logs. That brings us to the end of this project. All the instructions for adding the filters and setting stuff up, I've written them out all in this README. So read it closely and try to work on this same project. If you have any questions, leave it in the comment section below. Please like, comment, and subscribe to my channel for more videos like this. Before we leave, I'm gonna delete everything. You have to do a cleanup. Now, because we set up everything inside namespaces, we don't actually need to delete the deployments and parts and stuff one by one. You just delete a namespace and it takes all that away. Okay, so if I delete the login namespace, that takes away everything, including Elasticsearch, Filebeat, Kibana, deletes all that. That's gone. If I refresh the Elasticsearch page, you see that it's gone. Close it. NGINX is still up, and apps 1 and 2 are also still up because their namespace still exists. So if I refresh this page, it's still available because I haven't deleted its namespace. Let's delete it now. Demo apps is also gone. Now refresh it and it should be gone. With that gone, now we can stop our Kubernetes faster. Stopped, and so we can delete it now. I'm gonna delete all profiles so that everything is completely deleted. So press enter and everything is deleted. Please like, comment, and subscribe to my channel for more videos like this, and I'll see you on the next one.